browser doing? Server just starts listening for socket connections. It's, Google is out there somewhere with an open socket just waiting for new connections. Some browser goes to google.com. Server says, OK, I accept that socket. Now they both have a socket open that they can communicate through. The browser sends a special piece of text. This is part of the HTTP protocol that we won't go into detail. But basically, it sends get / that's because I didn't put / after google.com. I just said, give me all of google.com. So the server is just waiting to read on that socket. It will receive these bytes plus other stuff, but just the basics here. It'll say, OK, I will give you the root of google.com. So I will write a bunch of bytes to that socket. And those bytes are basically plain text comprising HTML. And HTML is something that your browser can take and render in a certain way. And then as soon as the server closes that socket, your browser knows that it's done, and then it will then display the page. So there's some image here, there's a little text field, buttons, all of that was specified by the HTML that the server sent back to your browser. Okay, at this point, the socket is closed, there's no connection open, you have a static page displayed. But now you can do things like type something into your text field. And still static. This is all just happening locally on the browser. But then as soon as you click the button to search, then your browser says, OK, I will make another request to google.com. But this time I will say google.com/search. And so I'm going to a different part of Google. And this time I'm saying, oh, I actually have something to look for. So another socket is open. Your browser does another kind of HTTP thing, this time called a post. And it says, and it specifies there's this variable Q, or query, how to internet. And then Google replies, it sees that, builds up some HTML, sends it back over the socket. And then, of course, there's a BuzzFeed article, 10 tips on how to internet better. That is actually the top when I tried this. And there'll be a bunch more there, but this is basically the server is dynamically constructing HTML based on the URL and the queries that your browser asks of it. Okay. So let's write a super simple, tiny little web server that will sort of act as a chess browser. So we could make a web chess browser just as well as we can make a native application chess browser like you're working on. I've already got it started. So I have this simple little class called web server. I'll quickly walk through a couple of things. I just have this constant static string HTTP OK header. That is just part of the HTTP protocol. It's something you always have to send with a reply to a web browser so that it knows what to do. I have the OK header, and then I have the bad header. So I have like status 200 versus status 404. And my web server is going to decide which of those to use based on, like, if they went to webserver.com/ some URL that doesn't exist, then I will send the 404 header back. Okay, and then here's main. It just starts this kind of infinite loop that is trying to accept sockets. Just like on the diagram, google.com, up here at the top, the very first thing it does is just start listening for sockets. That's basically all that does. And when a socket is created, in other words, when a browser connects, then it runs this handle HTTP connection, okay, which kind of just is a stepping stone, a trampoline point for serve HTTP request. I've got just some kind of debugging info in here, so my server is going to show what the browser requested. And then here's kind of the core of it. Basic logic of a web server. this request thing, this is just a string because HTTP is plain text. So I can just look for certain things. Are they asking for slash? Then I will send and close, send on that socket and then close the socket the home page of my tiny web server. This is the entirety of the home page, just one little giant HTML header. Okay, if they are looking for slash players, then I will send the OK header plus get players HTML. And we'll go look at that method shortly. Otherwise, so if it's not get slash or get slash players, then I just send, bad header plus page not found. Okay, that's all a web server is doing. It's some logic, looks at the HTTP request, decides what to send back. Pretty straightforward. So let's go look at this get players HTML. Actually, let me just run it. Let's run it right now. Let me make the font readable. So I have here a browser that's, I'm going to point to localhost. And here's a web page. And my web server has said, here's the request that the browser sent. There's a lot of other stuff in here. All it really cares about is this. This is the only thing it's looking for. And that's how it decides what to send back. Okay. But let's go and look at this. Let's say if I were to put in localhost / players. Let's see what that will do. So it makes a temporary result. It's going to just add stuff to this. Makes an SQL connection, just like we've seen, just the standard stuff, opens the connection. Then we're just doing select star from players. So just give me every single thing out of the players table. And then all I do is loop through that result and append to the result the name of the player. And then I return it. Okay, so that's just going to be HTTP OK header plus this giant string containing the name of every player. So if I load that, it is a lot of data to go and get the list of all players, especially over a kind of crappy connection. Let me restart the web server. Okay. So, not very pretty, but it gives me the list of all players. And the problem here is that I'm just returning plain text, which web browsers are capable of displaying. But if we wanted to do something a little more readable, that is exactly what HTML is for. It's a language that tells a web browser how to render something, how to display something. So instead of just returning a giant string with all the players' names, let's start with by putting it into an HTML table. And then inside of here, so result plus equals reader name. I'm going to put every name on essentially its own row in a single column table. So you don't have to be HTML experts. I'm not. Some of you probably know this better than I do, but I will just kind of show you the basics of building a table in HTML. So we will first do result plus equals table row. And in each row, there will be a table data. So that is basically saying, here's one row, here's one column of that row. Plus, reader name plus, and then we just close up the table data and the table row. And then instead of returning result, we first close the table. Okay. So refresh that page. And now it's a little more readable. So the point I want to make here is that the code we wrote, I'm not returning a hard-coded static web page. I'm taking whatever URL they gave me, doing a dynamic query out of a database, which is going to return who knows what. But I know that it's at least going to be just some list of rows. So I can loop through all of them and just build up HTML dynamically that my browser can then display. And just to make sure, yeah, so there's our favorite player, Magnus Carlsen. They're all in there. Not the most useful, but just a simple example. You can imagine putting in HTML form elements like text fields and buttons that would make this work exactly the same way as the native app that you're making. Question?
Is result a string type?
Is result a string type in the code here? Yeah. Yes.
How big can that get?
How big can a string get?
Yeah.
No limit in theory. Limited by basically the hardware on your machine. This is a very, very naive web browser. I'm doing this, so this result plus equals on a string is extremely slow. Normally you would use a string builder or something. There are way smarter ways to do this, but that's not really the point for today. Okay. Yep.
When you start your return with closing the table, if result starts with opening the table, and you would put result after, doesn't it mean it's going to go close and then it creates an open table?
Oh crap, you're right, yeah. HTML is very forgiving. Like that was absolutely invalid HTML, it should be that. But it's still kind of just figured. The browser just like, it probably meant this. Okay. So that's a super simple, very poorly engineered web server, just to give you the idea that all it's doing is looking at URLs, making some decisions about what to send back, and it can dynamically create HTML, obviously. So let's look at kind of the proper way or better way to make a web server, and this has all been thoroughly studied and figured out, especially recently. And this is not specific to web servers, but it comes down to the most important principle in software engineering is separation of concerns. There are other names for it, other terms for it, but the basic idea is decomposition of an extremely complex machine into simpler parts that fit together. It would not be possible to make complex software without this idea. So basic idea is write a function that does some specific task instead of writing the exact literal code for that task in line wherever you need it. And this extends up to things like make a class that contains similar functions or functions related to a certain thing. Put that class into a project. Make multiple projects that all separate things into similar or like concerns. And this applies to software engineering in general, but for things like web servers and for things with graphical interfaces, the formalization of separate concerns is an architecture called model view control, which you've all probably heard of. And basically, it splits it into three categories of concerns: the model concerns, the view concerns, like what is visually displayed, and then controllers, things like logic. So why? Let's say, what if I want to have two different views or two different ways of displaying the same information? What if I want to unit test the logic? If the logic is hard-coded into the code that handles a button, then you cannot test it without clicking that button. In other words, you can't test it without having a human sit there with a mouse. And just if you want to divide the programmer workload, like I wrote all of the front end for this web server, and you're going to be writing the back end. That's a reasonable, realistic division of work in the real world. So looking at the chess browser using MVC, so I have model, views, and controller. Let's look at the views first. So they're kind of small screenshots, but that one on the top, that's just a screenshot of a web browser, exactly like what we just saw. And then the one on the bottom is a screenshot of homework 5, the homework you're working on right now. Two different ways of interacting with the chess browser, but the end goal is exactly the same. And if we have sufficiently separated the concerns, then I can write one controller that both views can use, as long as there's some sane and common interface. And there is. I've provided two functions for you to fill in your controller: upload games to database and perform query. So all my web browser would need to do is take a bunch of stuff out of some HTML form and pass it into perform query, like who's the white player, who's the black player, who won, stuff like that. And then the model is just the basic representation of the data. And these are the suggestions I give in homework 5. You can do it however you want, but obviously you're going to have some kind of class that represents a chess game, some object that has fields in it, and then some static thing, PGN reader, that parses the PGN file into those chess game objects. Okay? And then you could reuse components of this to make all manner of different views, and without even really knowing the details of, like, how do I read a PGN file? Or how do I perform an SQL query? So you could write the front end without knowing anything about SQL. So in general, in a web server, it matches really well with MVC. The model is basically the database. So the tables in the database define the models. And you'll take your database and then write C# classes that essentially mirror those tables. So you'll have a C# class called students. You'll have a C# class called assignments, assignment categories, stuff like that. And then the view is just HTML, CSS, JavaScript, stuff like that, things that tell the browser how to display stuff. The controller then so the view will kind of allow the person to click certain buttons or do certain things, which will trigger certain controller actions. It'll say, hey, give me the list of classes in the art department. So your controller will then generate a query, okay, select classes where department equals art, or whatever. And additional logic that the model or the tables can't necessarily handle, such as in the LMS, the tables do not in any way prevent two classes from overlapping in time in the same place. It's hard to do that in tables, so we'll do that with controller logic. Okay. So let's take our tiny web server that we just had that was all in one file. The HTML was all in one file, the controller was all in one file, and everything. And let's kind of look at what would it take to start separating it out into MVC. But let's take our 5-minute break first. What it would start to take. So let's look at this method right here, get players HTML. it is essentially controller and view all in the same place. So I have this. So like, how do we know the view wants to display a table? That's a concern of the view. And then it has this. This is controller logic. This is how do we know how to get all of the players so the controller knows that. So a couple problems there already, but let's pretend this whole thing is just controller, and we'll deal with this view stuff later. Essentially what we would do, I'll come over here into the solution. And I know that's a little hard to read, but just kind of look at the basic structure of what I'm doing. So I would add, so let's go like into my web servers project. I would add a folder called controllers. And then in controllers, I can add, say, a class. And we'll call it database controller. Okay, and then I could go and take basically this whole method and paste it into there. Kind of along those lines. I'm not actually going to get everything compiled. I haven't added references and everything like that. But just to show kind of the basic idea. Okay, I've moved this into the controllers. Now, good. I'm starting to separate model from controllers from view. But the way I originally wrote it, and as I talked about, was we are like hard coding the HTML that we're returning. And if this is supposed to be just a controller method, then we can't do that. We can't assume how the web server wants to display the list of players. This thing's only responsibility, this is a bad name for it now, this should just be get players. Its only responsibility should be to return a list of players. Then the view can decide whether to wrap it in HTML or whatever. So what we would instead do is something along the lines of what we originally had, where we weren't adding HTML, we were just doing, like making up a big list of strings, and then we'd leave off all of this stuff, and so on. Okay, that's a little better. Now, when I call that, get players HTML, all this is going to do is something like controllers.get players, and then it'll do something like for each player P, wrap it in HTML or whatever. Now I can go and change get players HTML without changing the controller. They're kind of jammed into the same thing, and I can't change the way that it's displayed without going and mucking around with the controller code, possibly breaking it, introducing bugs, and so forth. So, okay, so this starts to bring up the question, though. How does the view kind of interact with the controller? How does it know what the controller is returning, or what format it's in? I've sort of written it this way, like it's returning an enumeration of player objects. And this is kind of an issue where if I'm writing the view, or if I'm writing the controller, I would have to know what the view has agreed that it wants, and if I'm or the other way around. They have to kind of know what the interface is between them. Does it return a giant space-separated string for the players? Does it return a C# list? Does it return a dictionary? Or what? Is there even such thing as a class called a player? Which currently there isn't, but you could imagine there might be. So let's kind of take a step back and just look at the basic web server architecture. You have multiple components here. You have Firefox or some client. You have the web server itself, and the web server is going to interact with a database. The parts of the web server, MVC is all in there in the middle in that gray box. And the view part is what it sends to the web browser. The controller part is kind of how it interacts with the database. So let's just kind of look. Let's say I have some code in the view and some code in the model. My view is going to do maybe something like that's like JavaScript. It's going to maybe do something like, okay, for every player returned by the model, add on a list item, so that's HTML. Add on a list item that just has the player's name. Okay, but that's kind of assuming that there is a class called player and that the model and that has a field called name. And the view doesn't necessarily know that. Before we go any further, we kind of go back to our attempt to separate this into MVC. I made my own little folder called controllers, and I kind of just copy pasted some stuff. That is already kind of not the right way to do this, because Visual Studio provides, since MVC is so common in web servers, Visual Studio actually provides a type of project that automatically sets this up. So let's create one. I'm going to go create a new solution. And if you go to web.net core, ask.net core web application. I will just call it like 13. So it actually supports projects that are web servers. And there will be some more options here. Sure, I'll save that. But before creating the project, it gives me another option here. Empty web application, and look at this one. Web application model view controller. So it actually directly supports MVC architecture in a web server. So let me click OK. Starting page is just kind of nothing we really need to worry about. I'll run this without really even looking at any of the code. It gives us a functioning starting point for a web server. It'll take a second to compile the first time. Notice, if you can read that, my play button turned into IIS Express. That is the name of the Visual Studio web server. Okay, and then it opened up a web browser for us. And it's going to point it at the appropriate localhost port. It always does take a little longer the first time. So just bear with us for a second. Okay. So they kind of just give you a very simple starting point, just like a couple little tabs at the top, super basic welcome screen. That, it by itself, is not really the point. What I want to show is, let's go back to Visual Studio and look at the code. So the solution is already structured, if you can see this. A controllers folder, a models folder, a views folder. We will look at home/index. And we will look at controllers/home controller. So let's start with index. Super basic, just kind of, this is the HTML for what it showed. There's that big welcome, there's a link to some stuff. But then this is not actually HTML. If you can see, I'll point it out on the, you can see on the video later, but the name of this file is index.cshtml. C# and HTML combined into one file. And this is kind of just a .NET thing that it does. So this little stuff up here, anything where you see an ampersand, an @ sign, that means here is C# code. So this is actually C# code setting some field in a dictionary called view data. that can be later used, and we'll see how. Home controller.cs. Not sure why it's complaining about a bunch of compile errors, but we saw that it was running. I think Visual Studio is just having a hard time here. But let's look at this. So here's the home controller. It has two functions, index and privacy. Those are the two pages I can get to from the home page. When I click on them, it automatically runs this controller. And as is right now, the controller is basically doing nothing interesting. It's just saying return view, which means go to the view with the same name, index.cshtml, and just serve up that page. But we could do, you can imagine, put some fancy database query in here and return some data to the view. Okay, so how though? How do we get data from here back into the view, which is kind of just like hard-coded HTML? And that's where that cool C# combined with HTML stuff that Visual Studio supports comes into play. First, let me just show you. So here's HTML. In the middle of my div, I can do this. @ means incoming C# code. And I can just do something like just start writing C# code. Int I equals 0, I is less than 5, whatever. And then, so let me wrap this inside of like an unordered list. Inside of my list, I can do li, and then I can just use that C# variable I. So this is actually a C# loop that is constructing up. So li just means list item. This is just going to be like a bulleted list that's dynamically constructed by C# code. And it usually does not take quite this long. It's not going to be this frustrating when you're actually working on it. But so there it is. There's my bulleted list that was generated with C# inside of HTML. So this is called Razor. Microsoft calls this Razor. It's really cool, and it's just like a really nice way to create dynamic HTML content. So still not that great though. This is just kind of hard coded. This is I'm saying go from 0 to 5. What if I want to go from 0 to X, something returned by the controller, which we don't actually know at creation time of the view. So that's what this view data dictionary thing is for. In my controller, if I come in here and I do something like view data X equals hello, I can now use that inside of the view. So I'll just put like a kind of after my loop, I'll do an li, and I will just use view data X. Okay. Really wish Visual Studio wasn't complaining there are a bunch of compiler errors here. It usually does not have this problem. Okay, so there it is. That thing passed from the controller to the view through a simple C# dictionary. Okay, great. So instead of this, imagine it's like fancy database query, view data, players equals result of database query, or whatever. Now my view can just use that big list of players that the controller extracted out of the database. How is this really working, though? So I said view data at x equals some string. I can also do view data at x, or I'll use another variable at y equals 50. Or I could do view data, my var equals new chess game, or something like that. The thing is, this dictionary, this view data dictionary, is mapping strings to objects, any kind of object. The hierarchy object at the very top of the inheritance hierarchy. So it can. That's how it's it's able to. You can put anything in here you want, because the view doesn't know really what you're putting in there. It doesn't know what a chess game is necessarily. So that kind of raises another problem, though, is let's say that it was a chess game. So I'm using like my var. And if I just display it like that, it's just going to use whatever the default toString is for whatever that object is. ToString may not always be enough information. So you could do, okay, well, let's do something like view data as chess game, dot white player, something like that. Problem, though, this is kind of starting to violate MVC. Now I'm saying, all right, well, I know that there's an object, a class called chess game, and I know that it has a field called white player. The view should not know the details of how the model is implemented. It shouldn't know, it shouldn't care. There should be some other way of the controller telling the view, here's the information you need to display. Okay. So here's kind of the basics of what we just saw. I can put C# code into my HTML, and I can use this little @ sign, and I can write for each loops. But I'm assuming there's something called player, and the player has something called name. What if the model suddenly changed, or didn't suddenly change, or just was this way all along and you don't know it? Instead of an actual player object, what if the controller just returns a list of strings? Then you'd have to go and change your view to accommodate that. And so you may be thinking, well, you're going to settle on some design and just go with that. But here's the deal for our class in particular. Every single one of you, or every pair of you, every team, you're going to be making your own backend for this web server. I don't know if you're going to have a class called player. I don't know if you're going to have a class called events, games, whatever. It'll actually be for the LMS, so students, classes, whatever. I'm not going to tell you what classes to create and what fields they should have. So my view code that I have provided cannot expect that it has something called p.name, for example. So what we need is some way of taking basically any form of however you represent your model and translating it into some common form that my view knows how to understand. And going even further with why MVC is so useful in a web server. The view itself is somewhat dependent on this stuff called JavaScript, so the server will send your browser some JavaScript, which is kind of like code that runs in the browser instead of the server just sending static HTML. Your browser will then actually run some code and figure out how to display stuff. That JavaScript that your browser is running has no idea what the model is or how the server represents the model. So it especially doesn't know that there's something called class player with a field called p.name. Okay, so big problems there. And it's just violating MVC in an extreme sort of way. So in the true spirit of MVC, the view should not know the C# or the source code implementation of the model or controller. And what this means is we need some standard interface now, like, well, it needs to know something, obviously. It needs to know it's displaying chess players. And the solution to this is actually, this is a slide from the very first day of class where we were talking about the relational model. The reason the relational model works is because the data is structured. We do at least know that the data will have something called a name, something called a major, something called a GPA. You might have additional private fields, or you might have even named them something else or represented them with different types, but we at least know that every object, every student object, is comprised of certain fields. For our purposes, we don't actually need the types. If we're passing information from the controller to the view, all the view needs is essentially string data, text data. So we can actually strip out the types, and as long as I can give it some form, some text form of how to display it, then it's fine. It doesn't need to know that it's a float. It'll just be a string with a dot with a decimal point in it. Okay, so this is called self-describing data. The description of the data is included in the data. So all of this together is basically like what we would send from the controller back to the view. But instead of making up our own weird format like this, we just use JSON, the JavaScript object notation. This is how we describe an object without knowing types, without knowing any implementation. It just specifies names and values. So and it's plain text. So now we know the thing that the controller returns to the view is plain text. It'll have a bunch of curly braces and brackets in it because it's JSON. As an example, like here is the object representing Magnus Carlsen. It just says name of the field, colon, value of the field, comma, next field. We can put arrays inside of JSON using a square bracket instead of an angle bracket. And they can be nested. So I can have an array inside of an array. I can have an object inside of an object. It can fully represent the structure of any data you want without knowing the actual C# implementation. I don't know if there's actually an array. I don't know if there's actually an object called game. Doesn't matter. Your controller will translate its model into something that the view is expecting. So all I have to give you is the names of the fields that I'm looking for. And then my HTML can render whatever you want it to display. Okay, so now we have this decoupling achieved. Since we have just some plain text format now, it doesn't even need to be C#. It could be C++, Python, Java. I don't care. I don't care what the classes are or how they're implemented. You convert it to plain text somehow in this JSON format. And the good news is about JSON, every modern language is going to have built-in support for it. Automatically serializing an object, deserializing an object. You don't really have to actually write code that goes through all of your fields and appends string to some text to some JSON string. Problem is, though, so what if you decide you want your field names to be something different because that's your programming style? But my field names, I have said that they need to be like W, capital E-L-O for the white L. All you do is you just put a property there saying this C# field gets renamed to that when you serialize to JSON. Problem solved. Then you can go and write your code, your class representations, your model representations, any way you want. Okay, so let me show you the actual web server now as one example. Here is one of the controllers that you might implement. I will give you basically this. I will give you the skeleton with full XML documentation of what it should do. So here's the get catalog controller. It should return information about the full catalog of classes, of courses in the LMS. And in order for my view to be able to display it, I tell you exactly what format it has to be in. Return a JSON array representing the catalog. Each object in the array should have the following fields. So I give you the exact names that you need: subject, department name, courses, which itself is an array, where every object in there has exactly these fields. Okay. So let me just run. I have to close the other one. Oh, come on. Sometimes Visual Studio gets itself in a messed up state. Yay, Microsoft. So we're going to look at get catalog. What I haven't shown you is I actually have an implementation of this solution here. But this is basically what I'll give you. You'll fill in the implementation. And I apologize for all the downtime here. Software is not working as expected. So let me just log in as one of the students. Go to the catalog. And so it displays all of this. You know, the format of these tables and the color and everything, that's all 100% a responsibility of the view. But the details that were filled in, obviously that's coming out of the database. So let me just show you a little bit of the view. And you don't really have to worry about JavaScript. You're not going to be writing any unless you want to. Here's how the view is actually asking your controller for the information. So it's invoking a controller called getCatalog. That is just the exact method right here. Okay, and then it's getting a bunch of data back as JSON. That is agreed upon. It's going to be JSON. And I have this thing in here, alert. That's just a browser alert. It'll pop up a little window in your browser. I will provide these alerts for every JavaScript controller call that I make, so that you can uncomment them, so you can see exactly what your controller is returning for debugging purposes. So I will put that in, and then I'll just come and refresh this page. Okay, and then let me copy this into something with bigger font. So I'll just kind of use Visual Studio here as like a scratch pad. So let's just look at this string of JSON and kind of format it so that it makes more sense. So it said it should return an array. Okay, so there is the start of the array. Inside of the array are departments. So here's subject name, art, department name, art with, so this is the abbreviation, this is the actual department name, and then it has courses. Courses itself is an array. Each one of those, 2200, CNAME, beginning drawing, there's another course, there's another course, and then that closes up the array of courses for the art department. This is just like a kind of a temporary course, a grading course. Okay, and then we get the next department, CS. Has its own fields, and then it has an array of courses. There's 1410, there's 6016, 2420, and so on. So your controller is just going to build up, it's going to do this database query, and then it's going to build up this giant JSON string, and as long as the format is correct, all of these names are correct, then the browser can go and fill in HTML tables with your information. And that way you don't need to worry about HTML or CSS. You will be free to tweak this a little bit so long as it doesn't change the functionality or like prevent us from actually seeing where the information is that we need to see. I'm not the best designer. This is like just a total like cookie cutter CSS template. Okay. So just to kind of wrap up what's going on here so you can wrap your head around it. But again, you don't need to really know the details of a web server and HTML and everything like that. You do need to kind of know the basics or it'll be easy to get lost. So .NET Core is the web server. It provides tons of functionality for parsing HTTP, parsing URLs, everything that just is not that interesting for us and you don't need to do. So a URL comes in, say it's foo/bar, $, x equals 1, y equals 2. Okay? .NET Core will automatically decode that into directory is foo, page is bar, view data x is 1, view data y is 2. And it will figure out which controller to run. It will go into, or which view to display. It will go into views/foo/bar.cshtml. That's the URL maps directly to basically the data structure, the folder structure in your solution. And then, so this has some HTML in it and some JavaScript in it and other stuff. So there's an empty table right now. And then I do this get x, view data x. That's what's called, that's an Ajax call, asynchronous JavaScript. Don't worry too much about how that works, but basically we'll load the page with an empty table, and then your browser will make another HTTP request saying, give me get x. Run something called get x. So it will go over to controllers/foo, foo controller, find the function called get x, run it, and it will return some JSON that will then get filled in by the JavaScript and will fill in the table with HTML. So just to kind of illustrate that, let me comment out this alert and go back and refresh this page and watch how it loads. No, no, I didn't save. Well, it's going too fast. But what I was hoping to show you is it will actually load parts of this page before it even knows what the details are. It'll load like the basic structure, like the title at the top. Yeah, you can't actually see that. And then you can see the copyright string comes up before these tables are filled in. That's because it's actually returning the basic HTML. Then the browser makes another request, which dynamically constructs those tables. Okay, that's it for today. We are out of time. See you next time.